So guys, this is how I do it. Ne? You start by saying sec, tan. Ne? That is the most important part you need to remember. Sec, tan. The bottom part is easy to do once you know the top. So what is the cofunction of sec? The cofunction of sec is cosec. Also here, the cofunction of sec is cosec. The cofunction of tan is cot. Do you get it? So, and then you also need to remember that the middle cosec has a negative. And then once you know how to recall this, trigonometric differentiation will be easy. Trust me, my friend. Let's do 20 examples using this table here. Ne? Perfect. So number 1, we are given y equals to sine x. And we are asked to differentiate this. So obviously we're looking for dy over dx. So you can just say y prime, right? So this one is a basic one that I expect you to know it. The derivative of sine is always cos. So the derivative of sine x is cos x, right? That one is easy. And then next one, number 2. The derivative of cos x. We need to find the derivative of cos x. The derivative of cos x is also too basic. I expect you to know it, which is negative sine x, right? These two are the basic ones that I expect you to know. The rest of them, we are going to get them from our small little table there. Ne? Perfect. But sine and cos, please recall them. Let's do the third one. Number 3. You have y equals to tan x. So here, we are going to use the table because tan x is there on the table. So the strategy is this. You just cancel what you are looking for. And then on that row, you multiply what remains. So if I cancel tan x out, I have to multiply sec times sec. Sec times sec gives me sec squared, which means the derivative of tan x is sec squared x. All right. I hope you're following, ladies and gentlemen. We're going to now dive into number 4. So, on number 4, we are given y equals to 2 sine x. This is also simple. So the y prime will be, remember, when you are differentiating, a constant will just remain, right? So I'll just still keep the 2 there and then do the derivative of sine x. As we said earlier, the derivative of sine x is cos x. Let's do number 5. Number 5, you have y equals to 4 cos x. Now let's do the derivative. Y prime would be, remember the constant will remain, so 4 will still be there. The derivative of cos x is sine x with a negative, right? So it's negative sine x. And then we're going to multiply the 4, so I'm going to have negative 4 sine of x. All right? Perfect. So let's now do number 6. So on number 6, we are given y equals to 3 tan x. I advise you to pause the video and attempt this one. The answer is y prime is equals to 3 sec squared x. Why? Because you cancel what you're looking for, you multiply the 2 terms that remains on that row. So we're going to multiply sec and sec, that give us sec squared, which means the derivative of tan x is sec squared x. I hope you're following, ladies and gentlemen. Perfect. Let's proceed. So I'm going to remove this and go to number 7. Right? So 7, we have y equals to sine 2x. Okay? Start to get a little bit interesting now because the angle is no longer x, it is something, right? So this is what you do. you always apply the same rule. So I'm going to say, okay, y prime is equals to, remember the derivative of sine is cos. So I'm going to say, okay, this will be cos 2x. You still keep the angle, but you always have to multiply by the derivative of this. So the derivative of 2x is 2, right? So I'm going to multiply this by 2. The reason, let me just take you back and show you why we're not doing this with the other ones. Ne? Remember we said sine x, when we derive it, it gives us cos x, right? We were still doing it, but we don't mention it because the derivative of x is 1. So it's like you're multiplying by 1 here, which will just give you the same result. So when you have x as an angle, you do not need to show the multiplication of the derivative of the angle, because the answer will always be 1. But any other thing, you always need to multiply by the derivative of the angle. So the derivative of 2x is 2. So in this case, our answer is going to be 2 cos 2x. All right. Perfect. Let's move on, ladies and gentlemen. We're going to do number 8 now. Let's do number 8. So on number 8, we have y equals to cos 3x. So here, ladies and gentlemen, I'm sure we can see that we are going to have the derivative as negative sine 3x multiplied by 3, because the derivative of the angle is 3. All right? And then when we simplify this, it becomes negative 3 sine 3x. I hope we're still together. I hope we're still following. All right? Let's move on. Let's move on, ladies and gentlemen. We're going to number 9 now. Let's go do number 9 quickly. I'll just erase the remaining parts. Okay. So, number 9. We have y equals to 5 sine x, and then plus 2 cos x. So this will give us what? Let's do y prime here. Okay, I'm going to use a different notation now so that you get used to different notations. This still means the derivative, dy with respect to x. Ne? So as this one now, we're going to use the addition rule of differentiation, which says we just differentiate each term separately and add them together, right? So the 5 will remain. So I'm going to have 5. The derivative of sine is cos x. So I have 5 cos x there. Plus the 2 will stay. The derivative of cos x is negative sine x. So I can do this to save time. I know that this one, because there was a positive, when I multiply by the negative, it will be minus. And then I'll have sine x. You see? So this part, negative sine x, is the derivative of cos x. And then the 2 and the 2 stays the same. And that's it with number 9, ladies and gentlemen. Let's go to number 10. I'm going to do number 10 here on the side. So let's do this. So number 10. If you check number 10, we are given y equals to, let's see, 6 tan in bracket 2x squared minus 4. And then we are asked to differentiate that. So y prime would be, remember the constant stays, so the 6 is still there. I'm sure you can see that we can even start by differentiating the inside first, right? And do the derivative of the entire function after. What I mean is this. A multiplied by B is the same as B multiplied by A. So the order in which you are going to multiply the derivatives doesn't matter. Ne? So, but the rule is you have to do the derivative of the whole thing and the derivative of the inside and multiply them together. So I'm going to firstly derive this guy, which becomes 4x. This guy here becomes 4x, right? Then the derivative of a constant is 0. So I just have 4x there. And then now, because I'm deriving tan, I'm going to circle it, which means is sec times sec, which is sec squared x. So I'm going to do this. I know that, okay, the tan will change to sec squared, but my angle in this case is 2x squared minus 4. When you derive the entire function, you keep the angle the same. All right, let's move on, ladies and gentlemen. Let's move on. So we're going to number 11 now. Let me just delete this part. We're going to take this part out. So now we have 11. So let's check 11. 11, we are going to have cos of 5x equals to y, right? Obviously, we're going to do y prime here. I'm sure now you can see that the derivative of the inside will be 5, right? So it's 5. And then we need to derive by the derivative of the entire thing. The derivative of cos is negative sine. So I'm going to have negative sine. Remember, you keep the angle the same way. So negative sine 5x, which is basically negative 5 sine 5x, right? I love putting them in bracket like this. Perfect. So let's go to 11. Let's go to, oh, we did 11. Eh? So we're going to 12 now. Let's do 12. So on 12, we are given y equals to sine x plus cos x. The derivative here would be the derivative of sine, it's cos. The derivative of cos, it's negative sine x. And that is number 12 for you, ladies and gentlemen. Now we can go do number 13. Number 13 is very similar to 12. I would like you to pause the video and attempt it. So we have 2 sine x minus 3 cos x. We can see that the derivative of that will be this, right? Let me just make space here. So the derivative would be, the 2 will stay, sine x becomes cos x, right? And then the negative 3 stays, cos x becomes negative sine x. This simplifies to 2 cos x. Negative and negative will give us positive 3 sine of x. So the answer will be 2 cos x plus 3 sine x. I hope you got it right, ladies and gentlemen. We are now going to, let's see what number we're doing. Okay, we are now going to 14, right? Let us do 14. So here we're still doing basic trigonometric differentiation. The next video will focus on other aspects of differentiation. Okay, perfect. But I advise you to watch this video until the end. So let's do this. Let's do this. So we're going to delete, and then we're doing 14 now. So 14. Let me just increase the size of the screen. Yeah, so 14, we have y equals to 7 sine 7 sine 2x, ne? Okay, and then we need to differentiate this. I need you to pause the video and attempt it. Right, so the 7 is a constant, it stays. We need to multiply by the derivative of the inside, so the derivative of 2x is 2. And then we need to derive the whole entire function, which is cos, because the derivative of sine is cos. So which is cos 2x. Let me write it down. 2x, which becomes 2 times 7 is 14 cos 2x. All right, perfect. Now let's do this one, right? Let's do 15. So for 15 we are going to have y equals to negative sine x. I want you to attempt that one. So this one is going to be y is equals to negative, remember the constant here is negative 1 basically, so negative 1, the derivative of sine is cos x. All right, let's now go to 16. I hope you're following, ladies and gentlemen. I hope you're following. So we're going to 16 now. Okay, so on 16 we're going to have y equals to negative cos x. So the derivative would be y is equals to, remember here we have a negative 1 which remains, and then the derivative of cos is negative sine. So I'm going to have negative sine in brackets. So but also here there's a 1 which gives me positive 1 when I multiply this one and that one. So the answer would be sine x. All right, perfect. Now let's go to 17. 17, I need you to pause and attempt. It's negative tan 4x cubed minus 3x. I need you to pause and attempt this one. So the answer would be this. The answer would be, I'm going to write it on top, ladies and gentlemen. So here there's a negative 1 which remains because it's a constant. Then I need to multiply by the derivative of the angle, which is going to be 12x squared, because this gives me 12x squared when I derive it. Then this one will give me minus 3. So it's going to be minus 3, which multiplies by this. Ne? The derivative of tan, remember you need to use the table. So the tan cancels, so you have sec times sec, which is sec squared. So I'm going to have sec squared, and then the angle was 4x cubed minus 3x. All right, perfect. So now we need to do this. We need to go to 18 now. Right, we have 3 more, ladies and gentlemen. I'm sure you are feeling confident now with deriving sine, cos, and tan. Right, the next videos will focus on other advanced problems. So the next videos I'm going to advance them, but we have to build from the basics. So let's do 18 now. So 18, you are going to have y equals to sine 4x, which differentiates to the derivative of the angle, it's 4, and then the derivative of the function is cos, and then the angle was 4x. Right, now let's do 19. 19, you have y equals to cos 2x squared, and then we also have plus sine 3x cubed, and then we need to derive this. let's get the derivative. I will firstly multiply by the derivative of the angle, which we can all see that is going to be 4x. And then the derivative of cos, it's negative sine. To save time, I'll just put that negative here. And then here I'll write sine 2x squared. So the derivative of this is basically negative sine 2x squared. And then the 4 is the derivative. This one will give you this one, the 4x. And then we need to keep on going. So we're going to have plus the derivative of this angle, it's 9x squared. So we have 9x squared multiplied by the derivative of sine, which is cos. So the derivative of sine is cosine, which is 3x cubed. All right, now let's do the last one, number 20. Number 20, we're going to have y equals to tan x plus sin x plus cos x squared. So the derivative would be the sum of the derivatives, right? So the derivative of tan, I'm sure from the table you already know that is going to be sec squared x. The derivative of sine is cosine of x. And then here I need, because the angle is not x, I need to firstly start by differentiating the angle, which gives me 2x. Then the derivative of sine, of course, is negative sine. So I'll write there sine x squared here. The negative, I'll put it there. Because initially here it was supposed to be a plus. A plus times a negative is just a negative. And that's finito with this video, ladies and gentlemen. Aluta continua. Tango.